Hello, everybody. This informational video is on playing with light, a physics lab, which is reference to the one of your labs that you did during week 11. And so let's get right to it. Okay. And so this is just a shadow lab. We are trying to measure either your height or the height of Mr. B or the height of a tree or whatever object it was that you found around your house. And pretty much that is what you have to write. Depending on what data you used in your lab for week 11, that is what you're gonna write in this purpose in this box. Okay. If we go to the slide number 3, if you use Mr. B's data, use the red boxes to list your measurements in meters. So if you used Mr. B's data, okay, this is pretty much what the data is, except for this one. This one is actually wrong. I just made it up. I just made it up. This one I just made it up so that you all actually have the right numbers. The 59 inches and the 174 inches I got from right here. Okay, that is where I got that information from. Okay, but the red post shadow length is not 98 inches. I'm not sure how much it is actually. You're just gonna have to watch the video. Okay. And so this is the data that I would be using if I chose Mr. B's data, and so that's what I would be putting right here in these boxes. Okay, so let's see. So the red pole, not tree. So the red pole, the height of the red pole is height of red pole 59 inches. Okay, so 59 inches. So, oops, 59 inches. And then the Mr. B shadow is, let me put a box right there. And then another box over here. Okay. And it says that the shadow is 174 inches, 174 inches. So Mr. B's shadow length is 174 inches. And the red post shadow is 98 inches. That's a fake number, okay? Again, that is a fake number. So you have to watch the video in order to get the correct answer, okay? And so we're gonna go ahead and change these numbers to meters, okay? Okay, and so we converted 59 inches into meters, 174 inches into meters, 98 inches into meters. And how do we do that? Well, we go into Google and say, okay, Google, I need 59 inches into meters, and we press enter, and it gives us 59, 1.4986. Maybe we want 174, and it's 4.4196 or 4.42. Okay. And so please use Google to make those conversions. Okay. And so now, if you use your own data, that is a little bit different because those numbers are different. So if you use your own data, you had to know your height and the length of your shadow, and for the object, you only needed to find the length of the shadow of the object. Okay, and so maybe you are 6 feet or 72 inches. okay? 72 inches tall. And then maybe, and so this is the information that you have, okay? Maybe you are, the length of your shadow at that point was 106. And so we do 106 right here, 106 inches. And the length of the shadow of the object, maybe it was 124 inches. So we're gonna write 124 inches, okay? And so again, you need to convert those numbers into meters, okay, using Google. So 72 inches. So let's see, 72 inches in meters is 1.829, 1.829. And so we're gonna write over here 1.829 meters, okay? And so please do that for the other numbers, okay? All right. Well, and so that is how we type up our. So again, you either do this if you use Mr. B's data, or if you use your own data, you either have to do 3 or 4. You don't have to do both, okay? So you either do slide 3 or slide 4, okay? And with that information, everybody, with that information, we need to find the angle, okay? We only need to calculate one angle because according to laws of geometry, similar triangles have similar angles, okay? Similar triangles have similar angles. And again, imagine that the sun is over here. The sun is over here, and the sun is producing or um, vaya, throwing light, I guess. You could say throwing light. Throwing light. So it is shining its rays of light onto you and onto the tree. And so now you are casting a shadow onto the floor, and the object is casting a shadow onto the floor. And so the angle, we want to find the angle of the position of the sun. And that angle is going to be the same for you as well as for the tree, or for you as well as for the red pole, the red pole, exactly. Okay. And so if it says right here, use SOHCAHTOA to calculate angle at 1, okay? Post a picture of your work in the next slide. And so if you don't remember what SOHCAHTOA is, well, we gotta go into a week 7 folder. The week 7 folder has SOHCAHTOA notes, okay? SOHCAHTOA problems, and an example problem that you can take a look at. In the folder for week 8, we have a Pear Deck that we can, that we can use, and we have a tutorial video that we can also watch. Okay, so if you don't remember SOHCAHTOA, please make a reference to these resources that you have available to you. Okay. So let's go back to our lab. And so here is where we have our work. Again, you don't have to do what I'm doing. Okay, you can do this work on your notebook and then take a picture and post it on this. Okay. And so let's figure out what this angle is, everybody. So let me see my data. I'm going to use this data. Okay, I'm going to use this data. I have I'm trying to figure out what this angle is right here. And so I have the opposite side and the adjacent side. Okay. And so if I'm trying to figure out this angle right here, Okay, I'm trying to figure out this angle right here. The side right across from the angle, the side across from the angle becomes the opposite side, and the side next to the angle, the side next to the angle becomes the adjacent side. Now, how come this side cannot be the adjacent angle? Well, because this side of the triangle is the side right across from the 90-degree angle. And the side right across from the 90-degree angle is also known as the hypotenuse. And so that is why we cannot call that the adjacent angle. Okay, so the adjacent angle is the side next to the angle that we're trying to figure out. Okay, and so let's see. So we have opposite or an adjacent, and that means that we're going to use tangent. Okay, so we have that tangent is tangent of our angle is equal to opposite, the length of the opposite side divided by the adjacent side. Adjacent by the adjacent side. Okay. And so let's see. Well, it turns out that our adjacent, so let's see, length length of opposite side the length of the opposite side is equal to 1.499 meters. 1.499 meters. Okay, so 1.499 meters. And the length of the adjacent side is equal to 2.489 meters. 2.489 meters. Okay. Okay. So then we just plug in those numbers into our equation. Okay. So let's see. So then my tangent of at 1 is equal to let me see, 1.499 meters divided by 2.489 meters. Okay, and so now how am I going to solve this? Well, I'm just going to divide 1.499 divided by 2.489, and so let me set up the problem again at 1, and that is going to equal so 1.499. So let me see. I'm going to get my trusty old Google calculator, and I'm going to say 1.499 divided by 2.489 divided by 2.489, and that is going to equal 0.602. Okay, 0.602. 0.602. And so now what I need to do, everybody, So now what I need to do is exactly what it says on the to do on the document. To calculate the angle, use TOA from SOHCAHTOA, and that's what I did. And then I need to use the inverse tangent, tangent to the power of -1, calculator button, okay? And so I'm gonna use that. So I'm gonna use my inverse tangent, and that is gonna be the a calculator button, okay? Which looks like tangent to the power of -1. So tangent to the power of -1. Okay, and so I'm gonna apply that. I'm gonna apply that to both sides of my equation. So tangent to the power of -1 on one side, and I'm gonna apply it to the other side of the equation, like that. Let me fix this really quick so that it doesn't. Okay. And so now if I have a regular tangent and an inverse tangent, what happens is that I'm going to cross them out. Okay, that is what happens. Okay, so let's do a red line. They're gonna cross out. They're gonna get crossed out. And so now what I have is that my angle 1, is equal to the tangent to the inverse tangent, tangent to the -1 of 0.602. And so now I can do this this calculation in my calculator. Okay, so calculator, I need to ensure that I have the degrees. Okay, that the degrees are in dark gray, and I have this INV button right here. So I'm gonna press that INV, that inverse button right there, and look at that, tangent to the -1. There it is. Okay, so I'm gonna press that tangent, and it's tangent of 0.602 and equals to 31.048 or 31.05. Okay, 31.05. So now that's going to equal my angle. Equals to 31.05. 31.05 degrees. And that is this angle right here and this angle right here. Okay? And so now what I can do is I can figure out how tall the tree is, or how tall the object is, or how tall Mr. B is, because I have this information. If I have an adjacent side and I have an angle right here, okay, and I can figure out the opposite side. I have the angle right here and I have the adjacent side, and I can figure out the opposite side. How, you ask? Well, again, I can use my calculation over here, but this time, let me erase all of this. But this time I know the angle. This time I have, for example, I have the adjacent side. It's 4.420 meters. Okay, so 4.420 meters. So I have that the adjacent side, length of the adjacent side oops, the length of the adjacent side is 4.420. Is 4.420, and the angle at 1 is 31.05 degrees. 31.05 degrees. And the opposite side is what I'm trying to figure out. The height of Mr. B or the height of the tree. That is what I'm trying to figure out. Okay. And so now we plug in all these numbers into our tangent equation. And so I have that tangent is equal to, or tangent of 31.05, okay, is equal to, so again, the opposite side, I don't know what the opposite side is. So opposite, I don't know what the opposite side is. And this is divided by 4.420. And so now how do we solve this? Well, I need to do some algebra, okay? And I need to multiply all of this stuff to pretty much cross multiply. All right, pretty much cross multiply. I have to multiply 4.420 to both sides of the equation. Okay. So let me just write it up because I can't type it up. I can't write it. Okay, so I'm just gonna say multiply 4.420 to both sides of equation. Okay, and so now what would that look like? Well, that would look like something like this. So the opposite side, so opposite is equal to 4.420 times the tangent of 31.05. And so we can totally post that. We can totally do that on our calculator. Okay, so our calculator. So let's see, 4.420 times tangent of 31.05. Let me just make sure. So 4.420 times tangent of 31.05. 4.420 times tangent of 31.05. Okay, and we get 2.66. And so we have that. Let's see, did I calculate Mr. B's height? Yeah, I calculated Mr. B's height. Mr. B is 2 meters, measures 2 meters, 2 point, and I'll tell you why I'm laughing right now. 2.66, 2.66 meters. And if we do that into meters, if we if we do that in feet, okay. Let's see. 2.66, so 2.66 meters. 2 inches That is 104 inches, okay? That is 104 inches. That is 104 inches. That is 104 inches. And so what is 104 divided by 2? I'm sorry, 102 divided by 12. 104 divided by 12. Calculator. 104 divided by 12. That is 8 feet. That is 8 feet. So that is not. So let's see. We can do foot. There you go. So 8 feet. I am not 8 feet tall. Okay, I am not 8 feet tall. So I made that number up, 98 inches. Okay, that is why I made it up, because I am not 8 feet tall. Okay, and so I don't want to give you the answer. All right. So and then you have to do a little bit of research. Use the next two slides to write historical research about light. Use two different sources to find out how humanity has used light for its improvement or its betterment. List sources and post pictures. Okay. Just a little brief explanation should suffice. Okay. And there you go. That is how you do this this lab, everybody. Have an awesome day, everybody.